Hello students, good morning. Hello, good morning.
Good morning, ma'am.
Very good morning, Abhishekta. Right. Let me start my today's class. So where have we stopped in the previous class? Have we discussed about single input balanced output differential amplifier?
No, ma'am. No, ma'am.
No. Okay, today we have to start freshly this. Okay. Why I'm not going back is we have studied already dual input balanced output differential amplifier and dual input unbalanced output differential amplifier by spending lot of time, sufficient time on that. So previous class itself, I have mentioned that. Next class, I don't revise. I'll directly start single input and balanced output differential amplifier. Okay, so shall I start here? Single input
Yes, ma'am.
balanced output differential amplifier. Okay, so why we call this as single input balanced output differential amplifier? Any one of you? Only? Why we call this as single input?
Output taken at the two transistors, ma'am.
Question is why we call this as single input?
If
Talk
input
about
is given, only
only one input is
one
given.
input is given, ma'am.
Only one input is given. Very good, very good. Only one input is given. Other input is not applied. Okay, so other input terminal is grounded. So this is a single input. Now, just now your friend, one of your friend mentioned why we call it as balanced output.
Because we take
Output,
output at two collectors.
Output from both collectors of the
Yes,
transistor.
right.
output
We are
must
taking output at double end, right? Both the ends. That's why we call it as balanced output differential amplifier. Good. Right. Now, for any amplifier, what are the parameters that we calculate or we derive? Four parameters. What are those four? Voltage gain, current gain, input resistance, and
Output.
output resistance. Output resistance. Okay. So current gain is undefined, I have mentioned, right? So what is voltage gain? We also call this voltage gain as differential voltage gain, right? So AD. So AD expression we have derived for previous two configurations, right? Dual input balanced output, dual input unbalanced output. So what is the differential gain for dual input balanced output differential amplifier? AD is equal to
RC by RE.
yes, exactly, RC by RE. RC by RE. What is the differential gain for dual input unbalanced output differential amplifier?
RC by 2RE.
RC by
RC by
2RE.
2RE. That means when the output is
By 2RE.
unbalanced, when we take output at single end, it will be half of the double-ended amplifier, right? So it is half of the double-ended amplifier. So those two we have seen. So similar to that, and today we are going to learn about single input balanced output differential amplifier. Okay, so let us see the DC equivalent circuit. While drawing DC equivalent circuit, what we do? AC sources we short circuit. Therefore, this is the actual, corresponding circuit. And DC analysis is same for all four configurations we have studied. Therefore, when we carry out this DC analysis, the same equations what we have derived by using what KVL, which loop, all that, with the same procedure you will get IE and VCEQ, right? So this is DC analysis for your single input balanced output differential amplifier, right? Then while carrying out AC analysis, what are the steps we take? One is make DC voltages 0. Second step is draw small signal T equivalent model for the transistors. Okay, two transistors are there. So for those two transistors, we replace those two transistors with small signal T equivalent model. So by applying these two steps, we draw the AC equivalent circuit for the circuit which I have shown just now, right? So have you drawn that? First of all, have you drawn single input balanced output differential amplifier? Have you drawn this circuit? You please draw it fast,
No, ma'am.
right? Single input balanced output. You draw this equivalent circuit faster, right? Single input balanced output. So while I am explaining, you will be listening at the same time. Parallelly, you will be writing in your books also. So you please draw it fast. And once if you have this circuit, what we do, how do we draw the DC equivalent circuit? Make DC voltage 0, that means connect it to ground, and this voltage also you connect it to ground, and AC will be available. And in place of transistor, we draw what is that? Small signal T equivalent circuit, which I have shown earlier, right? So two times both the cases I have shown you. So by doing that, we can draw this equivalent circuit. So in place of this transistor, we have replaced this transistor with its T equivalent circuit, including current source, IC current, and all remaining things are same. VCC is connected to ground, and here VE is connected to ground, and actually second input is grounded already. First input as it is there. So this is a AC equivalent circuit for your single input balanced output differential amplifier. AC equivalent circuit. Okay. The polarities, everything, the transistor, the actual amplifier circuit what we have drawn, in that transistor place we have drawn the small signal T equivalent circuit. So you please note down this circuit, and this is very very important. You please note down this circuit, equivalent circuit, RE, small re in the regular place, capital RE biasing resistor here, and the input source V1 and input resistance here we replace with this resistance and input resistance of the transistor. Totally putting together, we replace it with R in 1 or R in, right? So R in or R in 1, whatever is convenient, we can write R in 1 or R in. Why? When we say R in 1, there should be R in 2 also, but only single input. So you can write R in 1. Similarly, voltage source also, V in 1 or V in or V1, anything you can write. Okay. So this is the AC equivalent circuit for your single input balanced output differential amplifier. So are you able to follow this circuit now? Yes or no?
Yes, ma'am.
Yes, right. So now we redraw this circuit again to make it more convenient to write all these KVL, all that. Okay. So now for any amplifier, what are the parameters that we are deriving? Differential amplifier especially, we are deriving differential gain, voltage gain, differential voltage gain, input resistance and output resistance. Input resistance according to the definition we define, and output resistance according to the definition we define. But when we see this differential voltage gain, the definition is differential voltage gain AD is equal to V naught by VI, right? So what is V naught? V naught is the voltage drop across, this is balanced output now. So voltage drop between this collector and this collector, right? So this RC and this RC. So therefore, in order to calculate this voltage drop across these resistors, we should know what are the currents flowing through these resistors, right? So in order to know these currents, we have to carry out some analysis. That's why we are drawing this AC equivalent circuit. Okay. So shall I move forward? Before I move forward, I'll next circuit, what we are going to do is this main RE, let us take this RE emitter resistor, and to this right side RE we keep, right? And then this left side also RE we will have, and at this junction, that means you just pull it down, and the resistor other end you connect it to ground here only, right? So that means I will just redraw this equation. You can see this circuit. You can see this ground also we have pulled down up to this, right? So you just pull down this point towards right, and this point towards left. You can see all the components like this. Okay, I just showed you RE as it is, and towards right side RE, and other points when we pull down like this, we'll get RC this side, and left side RE, and after that V in 1 and R in, and other collector junction, all these, right? I'll show once again the circuit. Okay, you just see RE, and this resistor RA, and from this junction ground, and from this junction IC2 and RC we have drawn. Similarly this RA and this RA, right? Left side this RA, and from this junction R in 1 V in, and from the same junction IC1 and RC. That is what I have drawn, right? This RA, this RA, this RA, and right side RA, and from that junction ground, and from that junction only IC to RC, and this RA and small RA left side, and from that junction R in V in 1, and from the same junction IC to RC. So this is the equivalent circuit. This is the most important equivalent circuit for your single input balanced output differential amplifier, right? So are you able to draw this circuit? From the previous circuit, you must be able to draw. Actually, if you draw it like this, it will be very easy for us to write Kirchhoff's voltage law at loop 1 and loop 2, right? After writing KVL, what we do? We get two equations, two loops, two equations, and two currents IE1 and IE2. We calculate these IE1 and IE2 in terms of input and other resistances, input voltage and other resistances, and after that we substitute IE1 and IE2 in terms of IC1 in place of IC1 and IC2. Finally, what we want to do is we want to calculate what is the voltage VC2 and what is the voltage VC1, right? That is what we are going to do. So have you drawn this equivalent circuit? I think you might have taken screenshot. Okay, that is good. But at the same time, you please draw it. Then only you will be able to write Kirchhoff's voltage law for loop 1. So I am talking about KVL for loop 1, right? So this loop 1, for convenience sake, I have shown in a very short form. Actually, loop 1, I am just drawing with red color line. You can see V in 1, this component, one term, plus this resistance, voltage drop across that, algebraic sum of voltages in a closed loop equal to 0, right? And voltage drop across this small RE and voltage drop across this capital RE equal to 0. This is the closed loop, right? So this is loop 1. Same loop 1 I am just showing for more clarity by drawing on the respective components. So this is loop 1. So how many components are there? 1, 2, 3, 4, right? So you can write this KVL for this loop 1, and similarly second loop I am considering in a different way. You can take completely like this, but it will be meaningless. So what I am doing is I am taking loop 2, right? Shall I draw loop 2? Yes, loop 2, voltage source, resistance, R in, voltage drop across R in, and after that I am going up little, right? Voltage drop across this RE, and again voltage drop across another RE, and then this one, and from there to here, right? So that is connected to ground means same thing. So this is loop 2, right? So these algebraic sum of voltages in a closed loop equal to 0. So these components you can take, and these KVL for both the loops we are going to write. So let me show you this, right? So first term is V in 1, and we start from the source negative terminal from here, right? From here we start. So therefore, again we reach that point. That's why minus V in 1 and plus IB1 into R in 1 plus IE1 RE plus IE into RE equal to 0. What is this capital IE? Let us see the circuit once, right? So in this circuit, let me erase these all these right? So okay, you just see this IE1, this is IE1, right? IE1 is flowing through this. After reaching this junction, this node, IE1 is divided into two parts. Whenever there is node, you know KCL, right? So sum of currents entering into the node is equal to sum of currents leaving the node. So IE1, this is IE1 entering. So what we have taken notation is this, we are representing as IE2, that is the current flowing in this direction. The difference of these two, that is IE1 minus IE2, is the current I capital E. That is the notation we have considered. That's why we got this IE into RE equal to 0, right? This is equation 1. Is this equation 1 clear to you? Is this equation 1 clear to you for loop 1?
Yes, ma'am.
Very
Yes,
good,
ma'am.
very good. Right, very good. So loop 2 equation I am writing now, right? So loop 2 I have shown you already, but once again I am showing minus V in 1 plus IB1 into Rn plus IE1 into RE plus IE2 RE equal to 0, right? So same thing I have written here. Minus V in 1 plus IB1 into R in 1, IE1 RE plus IE2 RE equal to 0, right? Then after writing these basic equations, what we do, wherever we have IB1, we replace with its IE1 by beta AC, and therefore this is a usual procedure we have carried out for what is that, both dual input, balanced output, dual input, unbalanced output, differential amplifier. Only new term that you got here is IE, which is expressed in terms of IE1 and IE2, thus is IE1 minus IE2. Okay, and again in our previous analysis also we have defined there why R in 1 by beta AC, then R in 2 by beta AC, why these terms can be neglected, we have defined already. So by doing all these modifications in equations 1 and 2, you will get equation 3 and equation 4, right? So rearranging these equations, you please do this rearrangement of these equations. Actually, I have done this rearrangement of these equations earlier for dual input balanced output in a very clear cut manner. Same way you please do, right? So our aim is to express this equation in terms of IE1 and IE2 and in terms of voltage source V in 1. So when we rearrange these equations, we will get RE plus RE into IE1 and capital RE into IE2 equal to V in 1, and similarly RE IE1 plus RE into IE2 is equal to V in 1, right? So after this what we do, ma? We got two equations and we got two unknowns. So to solve for this two unknowns, what we have to do? One of you respond. What we have to do? Yes, exactly, right? We have to apply Kramer's rule, right? So according to Kramer's rule, how we write this? According to Kramer's rule, how we write this? IE1 coefficient. So all of you write delta matrix. Delta matrix, one of you tell me what is delta? Delta matrix, you tell me what is delta?
Small RE plus capital RE
Larry
plus
plus
Yes,
capital
small re
R
plus capital Re, first term. Second term is
minus R
RE
minus Re, excellent. Third term, I mean
R E
Re,
R
Re.
E
After
R
that,
E
close
I1
brackets. Right, right.
I1,
That means
I2.
yes. This is R, and then here what we write IE1, IE2 is equal to. Tell me, is equal to
V1
V in one. V in one only. V in two is not here. Okay, so V in one only we got. Right. Therefore, you write this you write this these matrices first, R matrix, I matrix, and V matrix. You will get like this. Okay. So what you have mentioned only, you might have written in your notebook, but slow learners, if you are not able to follow, for the sake of slow learners, I am showing this slide again. You please write this matrix. Okay. So I hope out of 62 or 64 students, I hope many of you are following very well. Right? I need not use the word slow learner because all are very fast. Right? This is the matrix. After this, what we have to do, ma? Tell me, any one of you?
IE1 equal to delta 1 by delta.
Exactly. Very good. Very good. What is your number?
435
Let me
ma'am.
ask. Emma? 4?
35.
Name? 435. Name, please.
Revati.
Yes?
Revati ma'am.
Okay. Revati, right. Yesterday I kept that list in front of me. Today I just moved it little bit other side. That's why I did not see your name. Right, Revati, very good, excellent. IE1 is equal to delta 1 by delta. What is IE2?
Delta 2 by delta.
Delta 2 by delta, right? So you can write what is delta, right? So delta, just now you have mentioned about this matrix. You only have mentioned. So you expand this and you cross multiply and try to get the expression for delta, right? Cross multiplication, delta, that is delta, and delta 1 is equal to, first column is replaced with the constant terms that we have at the right side of the equation, and second column as it is. So second column as it is we have written, and first column is replaced with its constant terms. So again you cross multiply this and you will get this expression, and delta 2 second column is replaced by constant terms that are on the right side of the equation. First column as it is in delta we have written, and you expand this, you will get V in 1 RE, right? So like this, after getting the IE delta 1, delta 2, as you have mentioned, IE1 is equal to delta 1 by delta, IE2 is equal to delta 2 by delta, right? So what is delta 1, what is delta we got, and you simplify, that means RE, small re plus capital RE is equal to capital RE we consider, and therefore V in 1 into RE, and you just take here also RE plus 2RE, it is equal to 2RE. Therefore, in place of this, we have written RE, and denominator we have written 2RE. So finally, it is equal to V in 1 by 2RE, right? V in 1 by 2RE. That is IE1. Similarly, IE2, here we take RE plus 2RE, approximate it to RE, 2RE. So RE gets cancelled, and then finally what you get is V in 1, V in 1 by 2 RE, right? That means RE plus 2RE, you will be writing it as 2RE, and this RE and this RE gets cancelled. You will get V in 1 by this 2 into RE. So like that, IE2 is equal to V in 1 by 2 small RE, right? So after getting the values of IE1 and IE2, what we do? IC1, IC2, that means after that V0 we calculate, right? So output voltage V0 is equal to, output voltage V0 is equal to Vc2 minus Vc1, right? Vc2 minus Vc1. Okay. Now, what is Vc2? That is Ic2 Rc minus Vc1. We will get it as minus Ic1 Rc. Okay. So here, let me show you that circuit why we get minus Ic1 Rc, and then I'll come back. Right. I'll take you to that circuit. Here you can see. Vc2 is Ic2 Rc, right? And Vc1 is minus Ic2 Rc. Why this Vc1 is equal to, this side is grounded, right? So Ic1 is flowing in the opposite direction. Therefore, voltage drop across this is equal to minus Ic1 Rc. That's why we have written, right? That's why we have written Vc1 is equal to minus Ic1 Rc, right? Minus Ic1 Rc. Okay. And now, you know, Rc we take common, Ic1 plus Ic2, and after that Ic1 is equal to IE1, Ic2 equal to IE2, and just now we got IE1 is equal to V in 1 by R2 Re, and Ic2 or IE2 is equal to V in 1 by 2 Re, both are same, we got. So you 2 times V in 1 by Re, so you will get V0 is equal to V in into Rc by Re. V0 is equal to V in into V in 1 or V in into Rc by Re. After getting V0, what we do? One of you tell me. After getting V0, what we do?
Input resistance.
Pardon?
Input resistance.
No, V0 we got. After that, what we do?
Voltage gain. Voltage gain,
Yes,
ma'am.
differential voltage gain, right? So that's why we are calculating V0. Okay. So differential voltage gain AD is equal to V0 by V in 1. V0 is expressed in terms of V in 1, right? So therefore this V in 1, this V in 1 goes, and we get RC by RE, right? So this is a single input balanced output differential amplifier. It is a double-ended amplifier only. So we got differential gain is equal to RC by RE, right? So what is the differential gain for dual input balanced output differential amplifier? See the previous pages and tell me what is the differential gain for dual input balanced output differential amplifier?
RC by RE.
RC by
RC.
RE. Very good, very good. Then for the second configuration, that is a dual input unbalanced output differential amplifier,
RC by 2 RE.
RC by 2 RE. Very good, right? Now for this single input balanced output,
RC by RE.
RE, right? So that means if the output is taken at double ends, we will get output as differential gain as RC by RE. And if you take output at a single end, you will get half of it. Differential gain, you will get half of it. Okay. Then what is this is a single input balanced output differential amplifier. So therefore here we write only R in. You need not write R in 1, R in 2. No, R in 2 because it is a single input amplifier. Therefore Rn is equal to, how do we define what is the input resistance definition? Input resistance to the differential amplifier is the resistance measured at input terminal when other terminal is grounded, right? So that is equal to V in 1 by IB1. In place of IB1, as usual, you write it as IE1 by beta AC. what is IE1? V in 1 by 2 RE. So that you substitute, you will get Rin is equal to 2 times beta AC into RE. Have you written this intermediate step? Rin is equal to V in 1 by IB1, right? IB1. IB1 is equal to IE1 by beta AC. Therefore, in place of this IB1, what you write? IE1 by beta AC. So this you can write here, beta AC, right? Now what is IE1? IE1 just now we have written here. IE1, V in 1 by 2 RE. So V in 1 by 2 RE I write here. Now in this place, what I write? V in 1 by 2 RE. V in 1 by 2 RE. So this V in 1 gets cancelled, and this 2 RE goes up. Now you will get 2 times beta AC into RE, right? So that is Rin, input resistance of your differential amplifier. Single input balanced output differential amplifier is 2 times beta AC into RE. Is this clear?
Ma'am, once again say, ma'am.
Yes, right. Rin is equal to, according to the definition of the input resistance, Rin is equal to, Rin is defined as V in 1 by IB1, right? V in 1 by IB1. So actually if it is dual input, what we do? V in 1 by I in 1, V in 1 by IB1, at V in 2 equal to 0 we will say. But here only one input, therefore you need not mention about other terminal. So differential input resistance of the differential amplifier is equal to, Rin is defined as V in 1 by IB1. Have you written that equation? V in 1 by IB1.
Yes, ma'am.
Okay, right. Now you express what is IB1. What is IB1? IB1 is equal to IE1 by
Beta AC.
IE1 by beta AC, right? So that I have written here, right? So in place of IB1, you write IE1 by beta AC, right? Have you written that? In place of IB1, you write IE1 by beta AC. We have done this same thing. Same thing we have done for dual input balanced output differential amplifier. That's why I have not written these intermediate steps. Have you written IB1? IB1 is equal to IE1
Yes,
by
ma'am.
beta AC, right? Now what is this IE1? Just now we have derived what is IE1. I have shown you.
VI1 by
IE1
2.
is equal to V in
V
by
in 1 by 2 RE.
2 RE. 2 RE. Very good, right? So next step you write IE1, in place of IE1 you write V in 1 by 2 RE. Then you simplify, you will get Rin is equal to 2 times beta AC RE. Are you able to get this or not? Are you able to get Rin is equal to 2 times beta AC RE? Beta Acker?
Yes, ma'am.
Yes? Very
Yes,
good.
ma'am.
Yes, ma'am.
Ma'am.
Okay, right. So like that we define Rin for any amplifier, 3 parameters: differential gain, input resistance, output resistance. Differential gain we have completed, Rin we have completed. Now output resistance is equal to R01 is equal to R02 is equal to RC. That means what is the definition for output resistance? Output resistance is the resistance measured at the output terminal with respect to ground. So what is output terminal? Right. With respect to ground. So output terminal, this is the output terminal with respect to ground. Otherwise, this is the output terminal with respect to ground. So either at C1, VC1, you can take V01, you can take R at V02. Therefore, if you take here at 1, we say R01. If we take measure here, we say R02. So with respect to ground. Therefore, output resistance is equal to the resistance measured at output terminals with respect to ground. Only collector resistance is there. Between the collector and the ground, only one resistor that is present, that is RC. Therefore, output resistance is equal to RC. So like this, we can analyze single input balanced output differential amplifier, right? So how many differential amplifier configurations are there, ma?
4 types, ma'am.
4 and 4.
Configurations. First one.
Single input, dual input,
First
balanced
one.
output, dual input,
First one, dual input, balanced output, differential
balanced
amplifier.
output,
For that, we have calculated AD, R in, R naught. Second configuration,
dual input, unbalanced output, ma'am.
unbalanced output. Okay. For that also, we have calculated AD, R in, R naught. And third one, just now we have seen. What is this third one? Single input,
Single
Balanced output.
balanced output, differential amplifier. Then what is the last one?
Single input.
Single input, unbalanced output.
Unbalanced output, differential amplifier. Okay. So I think you can guess what will be the differential gain for single input, unbalanced output, differential amplifier. If the output
RC
is
by
balanced,
RE.
we get RC by RE. If the output is unbalanced, that means if the output is
RC by
single-ended,
2RE.
very good, very good. RC by 2RE.
2RE.
RC by 2RE. That's good. So for single input unbalanced output differential amplifier, differential gain is equal to RC by 2RE. Then what about input resistance? Single input. So previous case and present case, both the cases, input resistance is same. That is 2 times beta AC RE, right? So we are talking about single input unbalanced output differential amplifier. So what will be the output resistance? Fourth configuration, output resistance will be
Same.
output where we will be taking at one terminal only. So output will be RC, right? So this is the circuit what I want to convey. Single input unbalanced output differential amplifier. Previous case we have taken output at both the terminals. Now we are taking output only at one terminal, right? So for this only you have mentioned what is the voltage gain, what is the input resistance, what is the output resistance, all that. Okay. So previous case, single input balanced output differential amplifier, V0 is equal to Vc2 minus Vc1, right? So now for this unbalanced differential amplifier, V0 is equal to Vc2 only, right? Because we are taking output at Vc2 only, collector of the second transistor only. So therefore, just a minute, ma. Just a minute. Right. Just we take output only at one output, that is at Vc2. Right. So Vc2 is equal to Ic2 into Rc only, right? So Ic2 is equal to Ie2, therefore Ie to Rc. IE1 or IE2 expressions both are same. That is V in 1 by 2 RE. Right? Do you remember? Just now we have seen V in 1 by 2 RE. Therefore, you can just substitute differential voltage gain AD is equal to V0 by V in 1, which is equal to V0. V0 is nothing but V in 1 into RC by 2 RE divided by V in 1. Therefore, finally you get the differential gain what you have mentioned. Without deriving, you have mentioned it is RC by 2 RE. Now, you can just substitute this IE2 value, and you can also prove that differential gain is equal to RC by 2 RE. Is this clear to you? Single input
Yes, ma'am.
balanced output. Right. Good. Single input balanced output differential amplifier means we have taken V0 equal to Vc2 minus Vc1. Now it is unbalanced output. So we are considering only Vc2. Only Vc2 means just Vc2 corresponding values we are substituting. IC2 RC. What is IC2? IE2 RC. What is IE2? We have obtained expressions for IE1 and IE2, that is V in 1 by 2 RE. So same thing we have substituted and we got this, right? So RC by 2 RE, right? Then input resistance same as the previous case. That means Rin is equal to what is that? V in 1 by IB1, and same thing you can substitute. Just now we have derived clearly. So Rin is equal to 2 beta AC RE. And same way output we are taking across second transistor collector. Therefore only RC is the resistance when we measure with respect to ground, and therefore output resistance according to the definition it is equal to RC, right? So like that, let me show you the summary of all these 4 configurations. Okay, so everything, if you we have one what is that marketing strategy, buy one and get one. So if you buy one, you will get one more. Nowadays buy one and get two also, so many offers you are using, right? So now what I say is learn one and get 4, right? So if you learn only dual input balanced output differential amplifier, that's all, that is sufficient to derive any of these configurations. Okay, now we have seen 4 configurations. If it is a balanced amplifier, differential voltage gain is equal to RC by RE. If it is an unbalanced amplifier, it is equal to RC by 2 RE, right? If it is an unbalanced amplifier, the gain is equal to RC by 2 RE. And similarly, for single input balanced output differential amplifier, today we have derived it is RC by RE. And just now we have derived single input unbalanced output differential amplifier, its differential gain is equal to RC by 2 RE. So finally, for the differential amplifier, the differential gain depends on the load resistance or the collector resistance RC divided by the emitter resistance. The emitter resistance, that is transistor emitter resistance RE, right? And then if it is a balanced differential amplifier, we get RC by RE. If it is unbalanced, it is RC by 2 RE, right? This is what I want to summarize. And input resistance is same for all 4 configurations, right? Input resistance is same for all configurations. Output resistance is same for all configurations. That means whatever may be the configuration, first you learn this dual input balanced output differential amplifier perfectly, then required modifications you can do, and only writing KVL and what is that, after writing KVL, writing 2 equations and express them in terms of by using in terms of matrices, and then you you use Cramer's rule and you get expressions for IE1, IE2 and then V0, and after that differential gain, and after that input resistance, output resistance. Okay, so is this easy or not? I want to know from you. See, you are under JNTUK stream, right? So you are going to answer JNTUK question papers. We have 4 sets of question papers. So out of, from unit 1, these are the main questions that we get. Okay, so probably tomorrow's class I want to revise this these topics. From previous question paper questions also I want to discuss something. Okay, so out of 4 sets, 1 set you will observe, you will get this question paper, this question. Other set people will get this question. Another set this question. Another set this question. That's all. So therefore, all of you, I think if you learn dual input balanced output differential amplifier, you can score full marks in university examinations. Naturally, they will be giving this for 14 marks directly. They won't even split A, B or like that. Okay, so directly for 14 marks. Explain about dual input balanced output differential amplifier and derive the expressions for differential gain, differential input resistance, output resistance. That's all. So you have to draw, I think because you have to learn, I have given you each and every small intermediate steps. Otherwise you can skip some steps and do, because you got some practice. You will be writing the same questions in assignments, and you will be writing same questions in what is that, mid examinations. Therefore you will get some more practice, and finally in the end examinations you need not write all intermediate steps. Directly you can write small, I mean equivalent circuit, and here and there you can skip off and simplify, and you can write, and then it will be very easy for you to score 14 out of 14 from unit 1, right? Is it possible or not?
Yes, ma'am.
Yes, okay. So only KVL, writing equivalent circuit, KVL, I think blindly for all 4 configurations we are doing, right? So therefore, you please learn this, and then coming to the current gain of the differential amplifier, I told you after learning all the 4 configurations, I want to tell you. So this differential amplifiers are used as voltage amplifier only, and these are not used as current amplifier because current gain is undefined. Why this current gain is undefined means, let me tell you, for any circuit, you can say, if the, let me give you one small example. Some voltage is there, okay, some input voltage is there. With that, if there is some small resistance, if there is some small resistance, what will happen, right? There will be some current flowing, right? I is equal to some V by R. There will be some current flowing. If the resistance value is increased, what happens to current? If resistance value is increased, current value
Decreases, ma'am.
decreases. Very good. Current decreases. Okay. Now, resistance value is increased means what? Earlier, let us assume in the order of ohms. Now, I have made it kilo ohms. Then I have made it into mega ohms. Then still what happens? Current further decreases. Okay. Even beyond mega ohms, okay, giga ohms. Otherwise, still if I increase the resistance, if the resistance is low, it will be like a short circuit. Okay, if the resistance is low, then maximum current flows, it will be equivalent to short circuit. If the resistance is high, if the resistance is low, maximum current flows, right? So it is equivalent to short circuit, right? Now if the resistance is high, very less current, small current is flowing. Still if the resistance is high, then it will be equal to,
Open circuit.
very good, very good. It will be equal to open circuit. Then there will not be any Current will be equal to 0. Current will be equal to 0. So here in differential amplifiers, what happens means we use these as voltage amplifiers, and here we try to make input resistance very high so that current will be very less. Current will be very less. Therefore, very high input resistance means we use JFET, otherwise Darlington pair, all such things. Okay, so like that, what we do is, if there is some current, there will be amplification. So therefore we use these differential amplifiers as voltage amplifiers only, not as current amplifiers. For ideal cases, it will be equal to 0. Input current will be equal to 0. Therefore we can say that current gain is undefined. Current gain is undefined. Okay, now let us see, another concept, that is what is that? Okay, before, shall I move forward, or shall I recap once again? Single input balanced output. Just let me recap once. Today what we have studied, right? From here we have studied single input balanced output differential amplifier. Okay, so in this single input balanced output differential amplifier, we have taken this circuit, and after that we have drawn DC equivalent circuit, and after that DC analysis is same, and AC analysis respective steps, and we have drawn the equivalent circuit, and from this circuit we have just pulled at this junction, and we have drawn the equivalent circuit like this. After drawing this equivalent circuit, we have written two KVLs, loop 1 and loop 2. Like that we got two equations, equation 1 and equation 2. And after that, IB1 is equal to IE1 by beta AC, and IB2 equal to IE2 by beta AC. These terms we have substituted, and we have neglected two terms. And finally we got equation 3 and 4, and we have arranged them in matrix form like this. And these two equations can be solved for IE1 and IE2 by using Cramer's rule. And delta 1, delta 2 we have defined. From that we have defined IE1 and IE2. After knowing what is IE1 and IE2, we have calculated output voltage V0. V0 is equal to VC2 minus VC1, and V0 is equal to VC2 is nothing but IC2RC minus, why it is minus IC1RC, I have shown you in the circuit diagram, right? Current is flowing in opposite direction, therefore the difference of these two, so minus of minus comes plus RC into IC1 plus IC2, and finally we have expressed V0, which is equal to V in 1 RC by RE. After that, differential gain. For any amplifier, three parameters we are calculating: differential gain, input resistance, and output resistance. Differential gain is equal to RC by RE we got, and input resistance is 2 times beta AC RE. Output resistance is RC, and after that we have gone to the next what is that? Next configuration. Two, three times I have taken. Right. Okay. Then single input unbalanced output differential amplifier. So we know we are taking output only at one point. Remaining analysis is same as the previous case. Okay. So just now what we have done, same thing is suitable. Only thing is V0 is taken at one collector only. V0 is equal to VC2. VC2 is equal to IC2RC. So therefore only that we have written newly. Remaining thing is same. Therefore V0 is equal to VC2 into VC2, which is equal to IC2 RC. IC2 expressed in terms of IE2. IE2 derivation we got V in 1 by 2 RE. So therefore differential gain definition V0 by V in 1 or V in. So same thing we have written here. And finally AD is equal to RC by 2 RE, because it is unbalanced output. And similarly, we have similar to the previous case, we can define what is Rin and what is R0. So single input, unbalanced output, differential amplifier. So all these amplifiers putting together, we can give summary. So from this summary, what we understand is, first thing, differential gain, right? So there are four configurations of amplifiers are there. Out of four configurations, if the output is a balanced output, that means if we take output at a double end, or if the output is balanced output, then we get output as RC by RE. If the output is, that's why for the third configuration also, output is balanced output, therefore RC by RA. Here also balanced output RC by RE. Right? So if the output is taken at single end, gain is equal to half of the balanced one. That is, gain is equal to RC by 2 RA. Right? So one of you tell me, what is the differential gain for single input unbalanced output differential amplifier?
RC by 2RE, ma'am.
RC by 2RE. And what is the differential gain for single input balanced output differential amplifier?
RC by RE, ma'am.
RC by RE. So what is the relationship between these two? The gain of the unbalanced amplifier
Half
is
of
half of the balanced amplifier, right? What you have to mention? The gain of the unbalanced amplifier is half of the I repeat,
Balanced.
complete my balanced amplifier, right? The gain of the unbalanced amplifier is half of the balanced amplifier, right? In gate or in what is that? Gate or IES or IES, Indian Engineering Services, right? Or gate exam. In all these, they will ask this type of questions only, right? They'll give you a very big circuit and they'll just say calculate output resistance. Though there is a very big circuit, if you know that output resistance is RC, you can just write that value, right? And similarly, if you are asked to calculate what is the gain, otherwise they will give like this. The gain of the unbalanced differential amplifier, unbalanced output differential amplifier is A bit, half of the balanced differential amplifier, B bit, double that of the balanced differential amplifier, or none of these. Then what you have to write? Half or double?
Half of the
Half,
balance.
right? Half is, right? So single-ended means half, double-ended means full. That you remember, right? RC by RE is full and half of it is RC by 2 RE, right? So therefore, from this summary, if you observe, everything is, from this summary you observe everything is same for all configuration. That means, everything means input resistance and output resistance for all configurations is same. And gain only, if the output is a balanced output, then gain is RC by RE. If the output is unbalanced output, gain is RC by 2 RE. That's all, right? So what all we have learned for all in all these classes is summarized in this table, right? Summarized in this table. So most probably tomorrow's class I will give you assignment questions. So what I do is, if possible, I try to give you Google form. That means by providing some space for this. Otherwise, you can upload. You write in your notebooks and you can upload. That will be better. So I'll ask you to derive differential gain, input resistance and output resistance for dual input balanced output differential amplifier. One question. And all these configurations I'll ask this question, right? Because each set different question papers, different configuration will be there. You do not know which configuration you will get. So before going to the exam, if you have all these in your notebook, then it will be easy for you to have a glance, and it will be easy for you to score marks, and it will be easy for you to revise. Okay, so I think actually I thought of covering the next topic also. It will be what was that, over ambitious. So therefore I have not covered the next topic, and we have reached to the end of the class. It is 12:30. Let me also take attendance once again, and here I would like to stop my today's class. Okay, shall I stop?
Yes, ma'am.
Yes, ma'am.
Okay, okay. Then let me stop recording.